So let me begin. So we've covered this topic already on vectors and scalar quantities. And we learned that one example of a vector is the thing we call velocity. So velocity is having magnitude and direction, which is a characteristic of a vector. So the idea of our concept of vectors now is it is part of our physical quantities that is referring to or specifying something. This is according to its specification, whether it has direction or not. So the specification, again, in terms of specification, it's either vector or scalar. And velocity is one of this example, and its counterpart is speed. Speed will only have magnitude only. Now, we symbolize speed and velocity with letter V as a symbol. More or less or more likely, now we take it from the word velocity, the word V. And what do we divide when we solve for speed? We divide the distance, which is usually indicated by letter S, and we divide it with time t. So usually that's, again, S over t value. So S for distance or displacement, divide by time. So the unit of our speed and velocity are both in meters per second. Meters per second, but one will have direction. Okay, now the next example here is our average velocity. Average velocity is with respect to displacement. Now, we will see here that in this example, that there are two situations that are exactly the same, but their average speed and average velocity are different. Same situation. Now, look at the example. There's a car that travels in circular path, travels in a circle. Maybe that's a rotonda or whatever. And because it returns to its original position, so the car starts from this right side part of the circle, makes a turn and ends up again at the same location, that the displacement of this car will become zero because it is going back in a manner that it always goes back to where it started. So if we base it on displacement, the displacement becomes zero. So if velocity, average velocity is displacement over time, then displacement being zero, then the average velocity for this example will also be zero. So the average velocity here is 0 meters per second, because it goes back to where it started. But the same example, but we are trying to find this time the distance, or the average speed. So will the average speed also gives a 0? We will notice that it will not. The same situation, but the average speed is 50 meters per second because the total distance of this circle is 1,000 meters. It was estimated at least 1,000 meters, and then it took the object here 20 seconds to make the turn. So by completing the turn, so total distance over total time will be 1,000 divided by 20. So that gives you 50 meters per second for its average speed. So it has average speed, it has a numerical value for average speed, but it has numerical value of 0 for average velocity. So the difference between vector and scalar, which is velocity and speed. Okay, now, so I think now you understand that. Now let's take up another one, another idea about distance and displacement. So for our distance and displacement, let's say we are moving an object from right to left. So it moved a displacement of 5 meters to the right. That's the direction of the motion. No? 5 meters to the right. If you move it 5 meters to the right, the distance covered by that same object is also 5 meters as well. No? So distance and displacement are probably similar and the same for this first situation. No? Now, however, you decided to push back the object to the left. No? After moving it to the right, you decided to move it back 3 meters left. No? Minsan, ilo mo naman siya sa left, yung tulod mo pabalik. No? Now, how far is the object from where it started? So, 5 going right, 3 going left. So, may bilin pa siya nga 2 meters to the right. No? So, the new displacement of the object here is that it is now located 2 meters to the right. That's now a displacement of the object. No? That's the final displacement after considering situation number 2. No? But question, is that 2 meters to the right displacement the same as the total distance of the object? No? Now, if you'll try to consider the total distance traveled by the object this time, so we will be adding the first distance 5 meters right and then plus 3 meters left. So the total distance in this case is 8 meters all in all. No? So 2 meters is not an answer here because what we are looking for is the total length that the object travels. Now that's what we mean by distance. So the distance is 8 meters, but the displacement is only 2 meters to the right. Do you understand? Okay, next item na. So we indicate our vectors, guys, by using an arrow. And its length is usually critical. How long is the arrow is critical to the magnitude of our vector. So it will always have a starting point, which we call as the tail. And it will have a direction where it is going by pointing it with the head of the arrow. So our arrows have heads and tails. So 100 Newton force is much longer arrow when we draw it compared to a 50 Newton force. So we can also draw displacement. So number 3 is a displacement. Number 4 is acceleration. It always has a direction. And 80 meters velocity going south. So negative y-axis is also a way of telling us of its direction that it is going downward or south. So our vectors again are indicated by an arrow. The length of the arrow tells us of the magnitude. Now again, here is our situation about that student that goes to school. So first, from their home, he walks 40 meters north. And again, you can use your ruler, protractor to scale the drawing so that you'll be able to properly indicate on how much is the 40 meters in using your ruler. So maybe by graphical method, graphical approach, using ruler and protractor. And we need to also use some kind of a scale. We will correctly draw the thing that this student do by using some kind of a scale. So again, maybe in our scale method, we need to use a unit of measure there. 1 centimeter, for example, is equals to 10 meters of length. Para nga hindi kinsa laba-laba. So maybe you will apply here some kind of a scale here. So 1 unit of this drawing is 1 cm. And therefore, we are able to draw north 40 meters. Next, we draw the second part. Since the boy walked right or goes east. He walks for 50 meters east. And then therefore, reach the school. So question, how far is the boy from the school? Then maybe we will use that same scale and determine the third red line. No? So kung may ruler, protractor kita, pwede nato na gamiton and put it here on this red line, no? This third side. No? So maybe our protractor or ruler, no? Once we use it, no, and measure this side, no? Dili ka matakos ka na, no? You will measure this with a ruler. So ano nakalaba karon ng ining line, no? Ining blue line, no? Using your ruler. How many centimeter will you draw here, no? So perhaps, no, if you try to use your ruler, no, maybe you'll get something like 6.4 centimeter there, no? Okay, 6.4 centimeter. Since your scale is 10 meters, no, for every 1 centimeter, then you can multiply the 2 and get, no, the actual or the resultant displacement. No? Multiplying 6.4 na length with 10, no, that will give you 64 meters ang school, no, from the house, no. And then finally, the direction, we can get a protractor for that, no. You measure protractor, you measure this angle, and maybe, no, getting your protractor will now give you the value there, no. So maybe, no, using your protractor, you'll get an angle over here, which is equals to 51, no, 51 degrees, no, roughly, no. Oh, pakita nyo dahil yung protractor, no. You can use your protractor and then eventually have this one. So eventually, now the dr value, which we call as a resultant displacement, no, I'll call it d sub r, no. So d sub r, which is the resultant displacement, is now equal to, by graphical approach, no, 64 meters, and it is going, no, 51 degrees. That's east of north, no? So that's how we probably label, no, our, no, final resultant. So the school is going in that direction. So we call this as graphical approach, no, because we use ruler and protractor, no. However, by mathematical method or analytical method, no, we can use your Pythagorean theorem. And Pythagorean theorem, now we will square both sides, no, and add them and get the square root, no. And we also use, no, for the angle. So maybe here you'll need your 40 square, no. Okay, and you extract the square root value there, no. So you will have an accurate answer, no. So our graphical method is an estimate, no. That's the closest estimate, no. But the Pythagorean theorem will give us the actual answer. Maybe ang aton sabat di last time was 64.03 meters. And that's the exact value of the actual length, no. So this one is 64.03 meters. And the angle, theta, we take it by using arctangent, no? Arctangent of the opposite over the adjacent, no? And we get an angle value of 51.34, no? So our angle measure here is 51.34 34 degrees. So we can always approach it in two ways, no? Either by ruler and protractor or by analytical approach. No? So this one. No? Now, we will be introducing another analytical method next time, no, which we call as the component method. No? So we will try to learn how to apply the component method also in our application here. No? So again, this is what we call resolution of vectors. No? We try to find the effect of vectors together. So we apply it in displacement, resolution of displacement. Others would call this as vector addition. And we see here in this vector addition that 40 plus 50 is not equal to 90. 40 plus 50 in vector addition. So this is not, so that one symbol is not equal. The two pointed arrow, that means that it is not equal. So we have in algebra 40 plus 50 is equal to 90, but in this case it's not. The answer is only 64.03, and that's what we mean by vector addition. So in the next leg, so we know the answer if from their house to the school, that's the displacement and the distance. We already know it. So from the house to the school, that will be 40 plus 50. That will give you your distance. So if you are merely asking for the distance of the house, to school, and maybe the distance there is equal to 40 plus 50, which is equal to 90 meters. So that's how far he walked. But that's not the distance of the house to the school. Now, in the afternoon, after the school hours, the boy went home. So as he went home, he walked south, 40 meters south, and then he walked west, 50 meters until he arrives home. So question, what is the distance traveled by the boy in going home? From the house to the school going home. Now, what's the total distance traveled? In this case, the total distance traveled is adding all the distances that the boy walked. So that will be equivalent to roughly 180 meters. So the total distance he walked is 180. But its total displacement, what's the total displacement? In this case, the total displacement is unfortunately 0. And again, the same example showing us one has a numerical value, but the other has a numerical value of 0. So displacement and distance refers to two different things. Now, question, why is it 0? Because the boy returns home. So from where he started, how far is he from where he started? Then that distance or that value is 0, because he's back to where he started. But again, the total distance he walked is 180 meters. So that's again an emphasis on displacement versus again, distance is the length of the actual path traveled. Displacement is the length and direction of the change in position measured from the starting point. So that's why we have two different distinct answers earlier. So one is vector and the other one is scalar. Now, adding of vectors, we use this legend. These are our directions. Going up is north, going down is south, west and east are also left and right. If you use those words left and right. Now we can also use positive y, negative y. Positive x to refer no, going right, or left is negative x. No? So we can also use the words positive, negative y, positive, negative x for our direction. Now, we have here the three dogs, no? Prince, Cute, and Jupe. And these are things that they do. Now, let's start with Prince. No? Prince walked north 3 meters, and then he walked 4 meters west. So what is the displacement of Prince? Maybe Prince walked this distance, no? This dashed line. No? And that value is roughly, no? By graphical method, maybe that's 5 meters also. No? If you use your ruler and protractor. Now the angle is this one. No? This is west of your north. No? And more or less, that's 36 degrees. No? If you use your protractor, no? From the north. No? 36 degrees in. No? So this is the displacement of the dog. No? But how far did he walk? Total distance, it's not 5. No? But it is 7. No? Okay, so again, no? The answer above is distance, the answer below is displacement. No? Now, the second dog is Cute. Now, Cute walk right, no? Or walk east and covers a distance of 5 meters. So what's the displacement of the second dog, Cute? The displacement is 5 meters east, no? Because there's one displacement value. No? Distance is also 5 meters. No? So there's nothing to pair it with another vector. No? There's only one vector. So we just simply write that single vector. No? Next, the next dog is Jupe. No? Jupe makes a turn, no? And does it, no, in a circle. From the starting point, he goes back to the starting point. No? So therefore, if we talk about displacement of the third dog, no, its displacement is 0. No? So Jupe's displacement is 0, no? Because he goes back from where he started. But the distance covered by that dog, no, third dog, is equal to pi times d, which is circumference. No? Circumference is equal to pi times d, which is 3.14 times 2 meters diameter. No? So if this diameter of the circle is provided, then we can get the circumference. No? This red color circle. So multiplying, we get the circumference of 6.28 meters. No? So that's how far, that's the distance traveled by the third dog, Jupe. No? But his displacement is 0. No? So again, no, this is the third and last example that we have, probably last meeting. No? So I do hope you understand that. No? Okay, here are exercises that I wanted to try. No? So please answer this one. No? Okay, so we resume. No? Graphical method, our scale. No? It's important that you have a scale. Our scale is 1 cm for 10 meters. No? So for our north value, we may label here, no, 4 segments. 1, 2, 3, 4. Now, if that's equally spaced and properly done, then maybe we will now label our 4 segments north. So this is now our first vector, D1. No? So we could call this as D sub 1. What's the value of D sub 1? That's 40 meters north. No? Now next is 30 meters east. So maybe not from the tip of D1, not tip of D1. So the process that I'm employing is what they also call tip to tail. So we call it tip to tail. No? Can you hear me clearly? Class, can you hear me?
Yes, sir.
So we will now draw, no, from the tip of D1, our second vector 30 meters east. No? due east. So we will mark here 3 segments, 1, 2, 3, because we needed only 30 meters. No? So 3 segments only. No? And after that, now we draw our line. So the line, no? Let's say we will label it with a red color. So the 30 meters is only up to this point. No? And let me erase this one. So I call this now as our D sub 2. Okay, so D sub 2 is 30 meters east, no? And therefore, the third value here, no? So this third figure over here is now your resultant. No? So let's call it, let's have a green color for that. So we can call this as our resultant displacement. No? So again, that resultant displacement by graphing, maybe we will end up there with 5 segments. So you'll have here we have there 5 segments, no? And therefore we get a value 5 centimeter times 10, no? Meters per centimeter. So you'll have a total of 50 meters displacement. So it's important that you scale and you measure the scales, no? Multiply it by the scale equivalent. No? And the number of degrees is measured from here going to this particular point. No? And getting your protractor, more or less, no? That angle will be 36. That will be 36 degrees. Okay. So displacement eventually now, so dr, which we can call as our resultant displacement now. Our resultant displacement is 50 meters and it's going at a direction of 36 degrees. No? That's east of north. Okay, so that's the final displacement value using our graphical method. But others, I think, uses the Pythagorean theorem and the tangent function. Okay, but this is graphing. Okay, any question for this? Again, for number 2, what is the resultant displacement? And the resultant displacement again is sometimes labeled as dr. Now for this number, our answer will be also roughly 10 meters. And the angle is at 5 degrees. Roughly, that's 5 degrees south of your east. Okay, I'll just give the answer and let me illustrate it how we get or how we arrive at this answer. So this is our value. That's 5 degrees south of east, and our answer is 10 meters. And again, this is by graphical approach. This is by graphing. So again, how did we get the value? So again, so we will try answering the question, how did we get this answer? So again, our conditions are now we have 6 meters south. So D1 is 6 meters south. D2 is 10 meters east, and D3 is 5 meters north. So these are our three values. No? So we will try to draw this. First of all, we will try to draw that one after the other. No? So the technique again is by drawing it tip to tail. So our method is what we call tip to tail. Okay, so how do we draw the tip to tail method? So we start with the first vector D1. No? So we go south. Oh, sorry, no, this is not. I think we will have to transfer this above. So we'll start at the first value, no, going south. So we will mark 6 segments. 1, 2, no, 3, and maybe 4, 5, then 6. No? So maybe that's 6 segments going south. No? So this is our first value, D1. That's our D1, going south. And then we go east, no? East 10 segments. So 10 segments east. Five, this is 6, 7, no? 8, 9, and then maybe 10, no? That's our 10 segments, no? And again, no, going to the right. No? So let us label it with a red color. So this is our D2. Okay, we will erase the blue line so we will only see the red one. So this is D2, and then we go north, no? 5 segments. We move up. No? Now, more likely, no? Hasta lang na di siya kutob ang 5 segments. No? Because D1 is 6, so sa piyak, since it's only 5, then maybe now we can draw it shorter. So hasta lang di aton 5 segments. So we erase this line. No? So this is our D3. No? It goes north 5 segments. No? Now, where is the resultant? Resultant is from the starting point here today. No? So more or less, ining D3 natin, if we will use our scale, no? That will be 10 centimeters. No? 10 centimeters would be equivalent to 10 meters as well. No? Now, the angle, if you will use your protractor, no? If you will measure this angle here will give you around 5 degrees. That value will be 5 degrees, no, from the horizontal line. No? So that's why we have 5 degrees south of our east. No? So again, by graphical method, our DR, our answer earlier, our DR is 10 meters. And then the direction is 5 degrees south of east. No? So S of E is south of east ang ginamin tada. No? So that's now 5 degrees south of our east. Okay, so our answer here. No? So this is our answer for number 3 again. We draw the figure right, no? Left 20 meters, then south 5 meters, then 10 meters east, and the blue line is giving us now the resultant. No? If you measure it with a ruler, that will give you 11 meters. And by using protractor, our angle here no, will be equivalent to 26 degrees. No? That will give you 26 degrees, and that is south of your west. Okay, so this is our answer. No? Do you have a question?